Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning or good evening. It depends which time you see this video. My topic it is product discharge system. The shortcut of the product discharge system is PDS. This equipment what I'm choosing it is in the reactor area, exactly in polyethylene plant. Okay. Before go and answer the assignment, the question of the assignment, we'll give you a small introduction about what is the polyethylene. Okay, the polyethylene is the shortcut of the poly, and ethylene it is the hydrocarbon. The poly is mean of many, and ethylene is part of hydrocarbon, C2 hydrocarbon. Okay, in the reactor themselves, they have a reaction, and they have insert the chain in the reactor, and it will be, for example, like this one. Okay. We'll go back a little bit about what we are studied in the material subject. Like what we are remember in material subject, we call the type of the material, and they have many type of material. They have metal, they have ceramic, they have many type. But one part of the type it is the plastic, and plastic is coming from the polymer. Okay, now I will try to give you information and to be related of the what we are studying in the material subject. Okay, they have two categories in the plastic. They have thermoset and thermoplastic. Okay, what we are from our equipment, our plant is in the polyethylene, and polyethylene is will be under the thermoplastic, like what is shown here in the screen. It is the polypropylene. They have high density polyethylene, low density polyethylene, linear low density polyethylene, and polyester. And they have here thermoset. They have EP, PF, PUR, PT, HFE. Okay. From our area, it is in the polyethylene, exactly in the low density polyethylene and high density polyethylene. Okay. Okay. Now, if I want to, what is exactly, what's the difference between the thermoset and the thermoplastic? What we are studying before, we use the thermoset. It is exactly in the kitchen tools that I mentioned here, and the glass, and they have many things here. And we use thermoplastic about warp, food consumption, and the panel, lighting of the panels. Okay, we'll go back a little bit. What you see here, it is kitchen tools. Okay, when I say kitchen tool, that means it is applied of they have heat. Okay, if they have applied heat, what is the meaning of when they say apply heat? That means maybe it will be reshaped or not reshaped. But here thermoset, the difference between thermoset and thermoplastic, when apply heat here in thermoset is not will be reshaped. Okay, because that we use it here for kitchen tools, the thermoset. But here, if I apply the heat for the thermoplastics, it will be reshaped. For example, like here, thermoset, the heat will be heated and no reshape. Here will be I will include heated and it will be reshaped. This, for example, that for thermoplastic. But if I apply the heat, it will be reshaped. Okay, now we'll go through of the assignment. Okay, what is the PDS, product discharge system? This is a shortcut. Okay, the PDS exactly this one is PDS1, PDS2. In the reactor they have two PDS. In the PDS, the reason what is inside the reactor, the powder will be coming to the product PC is calling that product chamber and product load tank. Okay, the reason the purpose of the PDS, it is the outlet of the reason from the reactor. This is the first thing. Second thing, we don't want to lose the pressure in the reactor, because that we have line go back to the reactor. We try to don't lose any pressure in the reactor, because that they have some lines. And already I explained they have many lines. They have A, B, C, D, and H and E. All of them already I explained here in this slides. For example, about A is will be product valve, C is will be pair supply valve, D is will be product chamber from the PC reason outlet valve, and money valve like this, and already explained in this slides. Okay. Now the first question what we have here in the assignment already. The first question, what is the material we use in the PDS, in this equipment? What the material? The material what we use here, it is carbon steel. What is mentioned here, like the type is of the material in the PDS is the carbon steel, and they have many type of carbon steel. It's called SA 560 GR70. Okay. And here is mentioned typically of uses for AF 1670 plate is for high strength, low alloy steel plate like offer and optimum content of the strength. Okay, here also is mentioned here ASTM. This one is the shortcut of the American code. The specification of the covered carbon steel plate produced mainly for the application in welded pressure vessel. Okay, we need to be close of this word, welded pressure vessel. This application will be in welded pressure vessel, where improve the nose toughness is important. Okay, and they have here is mentioned also application including it will be bridges and building, and they have construction equipment, and they have structural tubing. They have many application for this carbon steel, exactly AS 516 GR70. Okay, the best material, they have one question here. Which one is will be the best material we'll use for this equipment in PDS? From our side and from our plant, we the best one it is carbon steel. The best material is used for this equipment, it is carbon steel. Okay, why it is the carbon steel? Why we don't have another material? No, the best one it is carbon steel. Why? Because for this equipment we need the pressures to be high, around 24 bar gauge, and it will be cycling of a dropping reactor product is will be 184,000. And this design is conservation vessel life. The life for this metal in this equipment is 30 years without replacement, like I mentioned here, without replacement. Okay, maybe somebody will be say, okay, all these properties we can put stainless steel. Why I use carbon steel? Yes, exactly, because the stainless steel is high resistance for the temperature, and high resistance of the corrosion also, and for the pressure. But we have one point, we cannot use the stainless steel. And if we choose the stainless steel, this material is not application in welded, like what I mentioned in this word, we need to make sure is not application in welded pressure vessel. Okay, because that we cannot use the stainless steel because it's not application of welded pressure vessel. Okay, now we'll go for the fifth question. What is the 9 different type of the corrosion? They have many type of corrosion. This question is general, and they have atmospheric corrosion, they have erosion corrosion, they have selective corrosion, uniform corrosion, beating corrosion, and fleeting corrosion, stress corrosion. They have many type here on this slide. Okay, they have question here, how we can prevent and minimize the failure and due to corrosion in this application. Okay, from our side we can minimize the corrosion by the insulation. This is the first and the best one for the insulation. I know somebody will be saying, okay, insulation we use for release temperature. Yes, for release temperature and for the corrosion. But we need to know they have two things. If you use the insulation, you need to have two things more. We need to have, you need to do 2 steps after the insulation. The first one will be seal painting with the surface preparation, and the second will be primer coat. This one is will be under the insulation. Okay, if I don't do insulation, they have 3 steps. If without the insulation, need 3 steps. Additionally, painting, one still painting with the surface like the first one. The second will be primary coat. The third one is will be this one, the point, if I don't use the insulation, top coat. Okay. Okay, here we got the question about the what is mentioned. The question is will be have allowing element and structure and characteristic. Okay. In the carbon, I choose 2 material like carbon steel. They have CO2 0.28%. Magnesium is will be 0.85% and to the 1.20%. And phosphorus will be 0.035%, and sulfur will be 0.035%. Okay, about the structure, like is mentioned in the slide, and characteristic is like the properties of this carbon steel. We have low strength, good formability and weldability, low cost, good toughness and tights, relative good strength, and hardness by the quenching. Okay, if I go for the second material, it will be stainless steel. This will be magnesium 2%, and chromium will be 10.5. CO2 is will be 1.2%, and other allowing element. And this one we have structure. And here in the characteristic will be corrosion resistant, high tensile strength, very durable, and temperature resistance, easily for formability and fabrication, and low maintenance, long less. And they have another one. Okay, the third, the last question about the purpose of the heat treatment is consists of the 3 steps. The purpose of the heat, if I want to say the heat treatment, they have the process of the heat treatment is consists of 3 steps. The first things will be heating. The second will be have soaking. The third will be have cooling. Okay. Type of heat treatment is will be annealing and normaling and hardening. Okay, what is the annealing and normaling and hardening? Okay, now we'll go through of them. This one will be general to explain all of them, temperature range of the heat treatment, and I will go divide one by one. I will try and explain for them. Okay, like I will say for the annealing. Okay, for annealing, if you make sure here, this one is the critical temperature and 720 Celsius. Okay, heating is above the critical temperature, and soaking for the 1 and 2 hours. Slow cooling, this is the point for the annealing. This will be slow cooling to release internal stress and radiant phase of or particle structure. This one about the annealing. If I want to explain about the normalizing, it will be heating material 40 to 50 above of the critical temperature. See, if you see here, this one the critical temperature 723. Annealing and hardening is will be very close of them, but normalizing is will be more than him. See here, the temperature is will be more than also 1000 Celsius, because that's here is mentioned the heating material 40 to 50 Celsius above of the critical temperature. Here is will be mentioned holding it for the about 15 minutes and cooling it slowly. Okay, now go for the end is will be hardening. Hardening is will be here, and is mentioned here is heating the material above the critical temperature, holding it to that temperature and quenching. Quenching is dipping the material directly, dipping like swimming. Okay, for the materials will be dipping the material directly into water, oil, and the polymer. Batch. Okay, purpose increase the hardness. Okay, like is already mentioned hardening. That's mean the pores, what the pores will increase the hardening and improve strength, toughness, elastic. Okay, this one about my presentation, and I hope you all of you, it is enjoy for this presentation, and thank you.